All right, so we're going to take a look at the device that I built, the reverse solar cell. So here's a look at the most basic parts. All right, so this is going to be the most important part. This is the centerpiece of the entire thing, mostly because it is not only because it's where all the power comes from with these Peltier tiles, but it is also exactly where we get the temperature difference from as well. It has all the temperature control. It has the absorbent heat sinks, which basically capture all the heat and then displace it onto one side of the Peltier tiles. And then you have the giant aluminum disc that basically also captures heat, but it does something a little different. It helps reject the heat. And here's how. This is the second important part that enables the disc to do its job. This is the reflective box, which holds the disc inside. And as you can see, there's a hole right here, which is where all of the heat sinks would go. They would fit snugly underneath. So that way it kind of isolates the rest of the disc here from the bottom of the container. So as you can see, it's just simply a hole that I cut in and added some insulation to, insulated tape. So yeah, those are basically the two most basic parts of this. And so what happens is when you put the disc in, I'm just going to kind of haphazardly put it in, but what happens is you put the disc inside, and what's going to happen is of course you need to put a covering on. So you need something plastic, or you could also use saran wrap, but I think the plastic covering is one of the better ones. And that explains the cloth here. It actually kind of creates a little bit of a seal from the wind. There is a little bit of damage to the cloth that I put up, but that's not really the point. The point is this container, basically the glass, the windscreen, helps keep the temperature low inside of the container. It's kind of like a fridge with a window. So yeah, so what happens is, of course, yeah, it acts like a fridge for a window of a fridge. And the disc absorbs all of the heat, because it's black, it absorbs all of the heat, all the thermal radiation inside of this space that's behind the window. And since it's facing upwards, and everything else that's surrounding it is reflective, it's basically just going to reflect all the heat back into the disc, and it's just going to keep reflecting it until all the heat makes its way over here on this area of the disc, and it just flies up into the sky, into the night sky. So it just basically radiates all the heat off, and it just slowly makes its way up into outer space. And that is the simple part of this side. And then the bottom, of course, that's the hole for all of the... No, they're supposed to be fitting snugly through, but they're not. But the hole basically enables it to stay situated on the ground, where all the ground heat is still kind of boiling off from the day. So the heat sinks beneath kind of just capture all that heat and then displace it onto the other side. And that's how you get the temperature difference inside of this reverse solar cell. So it does work. It definitely does everything that it needs to do. You might notice that the glass is a little warped here, this plastic glass. And it's because, yeah, I left it out during the day a few times for experiments, and it warps. It warps quite a bit. So you definitely will have to do something different. Maybe actual glass would be good. It's probably a good step up from that. And then not only that, but it also warps on the sides of the container. As you can see here, there's some warps. There's also a few burn marks. So it definitely does not work very well during the day. It does generate a lot more energy, of course, because it's in direct contact with the sun. So there's way more heat on top of the disc hitting the Peltier modules, and the heat sinks basically get so hot, but they also have the fins, so that helps dissipate the heat. Therefore, it kind of cools off on one side, so it generates a little extra power because of how much heat there is. But it's definitely not as efficient as a solar panel. Now at night, of course, it's way more efficient than a solar panel. I actually took a few blank Peltier modules and put them out. They don't do anything compared to this. They probably will do a few millivolts, but with these 8 modules, each of them are able to generate at max like 20 millivolts. And so I tried 8 because I didn't want to do 6, and it pretty much did the same thing. You leave the 8 inside, and each one would generate about 20 millivolts worth of electricity. And I got between basically about a tenth of a volt, a little over a tenth of a volt, which is definitely pretty usable if you run it through the correct circuit. Now that's kind of another part of this. It's a completely different part of the experiment, which kind of broke does not work very well anymore, so I cannot show you guys that, but this is the basic principle of it. So I definitely did create something that does show you exactly what you need to understand.